I'm Manar, I'm a geologist. I'm here with you today from Homerton College, and I have with me the lovely
Morag, sorry. We haven't practiced this.
We are ad-libbing everything. So Morag is also a geologist?
Yep.
Girton?
So my main abode is Girton College, but I look after the earth scientists at Homerton College.
Which is how we know each other. So we're going to talk to you today about these wonderful chalk cliffs. And the reason there are cliffs here are not natural. These are abandoned quarries. So we are standing where rock was extracted. It used to all be a continuous hill. But here we are, in the pit of the quarry after the quarrying stopped. So quarrying here started back in the 19th century, and they extracted building rocks to build some of the colleges, although we couldn't find any buildings, any college buildings with chalk in their facade. So we're speculating that perhaps it was a structural material and it's too ugly to be in the front. But the chalk group is a large group, and the Melbourne rock is one layer within that group. So it's a little bit hard to see in chalk, but there are actually different layers. And if you can find some of the more orange-yellow layers somewhere in the middle, they show you the dip. So up there, just next to that scree fall, can you see there's, something that's got black weathering, something dark, and then a softer, more weathered layer that's thin, and then another dark, harder layer? Can you see that? So that's showing you that there are layers to the chalk. So each layer has different properties, and then together, all of that makes up the chalk group, which is a very thick layer. And on your handouts, there's a geological map, and it shows you the outcrop in light green of the chalk. So the chalk that you have here is part of the same chalk group that outcrops, like you said, all the way down to the south of England and through to France. So the White Cliffs of Dover, the Seven Sisters, it's all part of this. And it's part of a much bigger chalk group that we see expressed all over England and Wales. But here it's at the surface. And in other parts of England and Wales, it's underneath the surface. Because if you can see there, it's dipping, it's going like that. It's not flat. So it's going like that, and then further away in that direction, it's hidden underneath. So the clunch is what the locals call the hard part. The very hard chalk layer is called clunch, and they use it for construction because it's a fantastic building material. But they also use the chalk, and especially the softer bits, the marly bits that have more clays in them, to produce lime. You need some clay as well. So quicklime is pure calcium oxide, which they use in cement and steel and glass and agriculture. And around here they used it for agriculture. And lime, without the quicklime, lime is that but with a bunch of other stuff. So if you add, oxides of aluminium or iron or various materials, then it's the more generic lime. And you use both lime and this stuff, chalk or limestone, in the production of cement because, well, you make lime out of this. So you take these guys. So chalk and limestone are made of a material called calcite, a mineral called calcite primarily, which is made of calcium carbonate. If you heat it up, you drive off the carbon and you end up with the calcium oxide. So that's your quicklime. You can add stuff to it and make sure you heat it, and that makes clinker, and the clinker is then powdered, and you add gypsum to the clinker and you've got cement powder. So if you just add water, then you've got a fantastic binder material. Very polluting. So we said calcium carbonate, we heat it up, we drive off the carbon dioxide. It is carbon dioxide that's driven off. And it is really worrying because cement is the main component of concrete. So if you take cement and you add some aggregates and sand, you make concrete. And concrete, turns out, is the world's second most used resource after water. So this is not a small pollutant. Okay, yes, you quarry, yes, there's intensive energy resources, but the production of it itself is extremely carboniferous, I was going to say, carbonating. So there's a lot of research that's being done on green cement. Can you do it the other way around? Actually, can we make cement that sequesters carbon? And so we lock it back in. And there's some of that going on in the university. But cement remains, and concrete remains, one of the hard to decarbonize industries. And we still don't really have a very good solution for it, at least nothing that's scalable yet. So if anyone has any ideas, come join us at Cambridge and help us work on it. Otherwise, we're going to come back to the quarry. So Big Pit, they stopped quarrying here in East Pit in the 80s. And since then it's been rewilded. But they abandoned Limekiln Close back 200 years ago. So it's had much longer to get rewilded. And the interesting thing is that some rare species of plants started to crop up because this environment, chalky grasslands, are a habitat that are becoming extinct in the UK. And so now it's a nature reserve because we're trying to protect what remains of these environments. And what you can see here is the different stages of rewilding. So it's been disused now and rewilded since the 80s, we said. And you can see, okay, we can still see the cliff, and you can tell that this was a quarry. You know, you can look around and see that this was a quarry. So you can see the different stages. Moss is the early colonizer, and then you start to get the grass. And they've actually reprofiled this area, so they've broken it up a bit to encourage the growth of the grass. And then after the grass, you start to get the woodlands. And if you walk around, you can start to see that. And the protected species are flowers that grow here. So the really exciting one is something called moon carrot. But I think it's a little early in the year to see it. When you come back, because I trust you all will now that you know it's here, when you come back in a couple of months, look for it. It grows literally out of the rock, out of the limestone. It looks like a carrot flower, but you can tell that it's moon carrot because the stem has ridges on the sides. It's not a circular stem. But for now, I'm going to send you hunting. Go have a look. What kind of plants can you find? Can you find any flowers at all? Can you see where there's moss, where there's grass? Go have a gander and we'll muster back here in about 10 minutes or so. Ooh.
Is that a thing?
And yeah, a fossil that you can see with the naked eye. Where's Morag? We will take this back to Morag.
Thank you.
It could be all of this, or
What is it?
a fossil. You see the
Yeah.
rings there, something.
There are some fossils to be found around here. They're just difficult to see, and there's not that many of them. So really well done. You have a very good eye. Did you notice anything about how the flora is distributed? So are the flowers in the same place as the lichen? Are the woods and the shrubs in the same place as the grass? Can you deduce anything from the distribution of the flora?
Those things like water.
Those things,
Like all the stuff growing over there.
yeah,
Is it lower, so it's wetter, so they like water?
very good. So we've got grassy type things in the lowlands, so water, it's where water accumulates. Here where it's very rocky, moss is the first colonizer. It starts with moss. That's a good name for a film. It starts with moss, moves on to grass. Within the grass, you start to get the flowers. Where did you find the thistle?
Just
In there?
yeah.
There we go. And it's that time of year where the flowers are just starting. So I think if you come back every couple of weeks, you'll see the different generations of flowers. This is a great place for it. So this is also a good place for nesting birds. There's 40 different types of birds that use this as a scrubland for nesting. So fantastic place for bird watching, a lot of butterflies and different insects. You do get all kinds of flowers, but they're seasonal. So it's being rewilded, right? Nobody is managing this. This isn't gardener's work. This is nature taking back the quarry. And so it does change with the shifting season. And it's actually really beautiful to see the changes and the differences over the spring and over the summer. Okay, so now if we start looking more into the edges, I see more shrubs and bushes and whatnot. And that's where you have more of that kind of thing, the scree falls. So it's broken up, soil is more easily established when you break up the rock, but you can't make soil without plants. So soil is not just weathering of rock. Soil is weathering of rock plus plant action, yeah? And so you start to see the soil forming in some places. Here, we still don't have soil, so mainly moss. Who wants to see the next stage of wilding, what it looks like if you leave it longer?
Oh yes, please.
All right, thank you. I love your enthusiasm. This is lime kiln close. So was disused as a quarry about 200 years ago. So this is what happens. It becomes a woodland if you leave it long enough. Look out if you find any cherry blossom. Is this it? Have I found some cherry blossom? So the cherry trees around here, there are some. They are actually descendants of the cherries after which Cherry Hinton is named. So they're mainly ornamental cherries. So please don't taste any unless you know what you're doing if you come back and they're in fruit. But go have a look and come back here please in maybe 5 minutes and we'll head back and talk a little bit more about it over there, okay? So if you look at this with a microscope, you'll see the bodies of the algae. So chalk is basically a rock made almost entirely of fossils that have then been compacted and made into a rock, but they're just microscopic. And that's why it makes really good, something to write with, because the cementation isn't that good. They're not that well bound together, and it's basically made of algae powder, and it just leaves a nice streak when you rub it on a blackboard. So on your handouts, there are some microscopic pictures of chalk under a microscope. So very, very high resolution and high magnification. And you see these little spheres, the coccolithophores. So this is an electron backscatter image. This is what chalk looks like if you zoom in high enough. It is beautiful. And this is just one type. So different chalks will have different species, but it's primarily this algae type stuff. Now, sometimes when you're out in the sea, other animals get caught in, like the ammonite that Mark found, the ammonite impression. Okay, so you get these animals, they sink to the bottom of the sea when they die, and you leave that long enough. So it's not disturbed, which means you know that you're not really on the shoreline, because we're not seeing any things like storm deposits that bring in material from the land. 2 million years of chalk. So you must be away from the shoreline, from the coast. So you're out in the deep-ish sea at least. It's not the very deep sea, because in the very deep oceans, calcite is no longer stable. So below around 3,000 meters depth in the ocean, the pressure of the water dissolves calcite back in the water. And so you don't get carbonates in the very deep oceans. That's called the carbon compensation depth. So we're in deep seas, shallow oceans. We know that coccolithophores live in very shallow seas, very warm seas, excuse me. So they live in waters that are around 20 degrees Celsius. That's very warm. It's a lot warmer than the seas are today. And you remember we said that this is part of a chalk group that outcrops all the way down to the south. So it covered most of England and Wales. Actually, we think that it was part of a massive oxygen depletion event in the atmosphere, where there was much more carbon in the atmosphere, much warmer, so think climate change, much, much warmer, mass extinction of things that rely on oxygen, but a lot of stuff that lives in the sea that builds its shells out of calcite. And so there's a lot of chalk in the rock record. This was in the Cretaceous period, so the UK would have been in sort of tropical latitudes in the Cretaceous, and that was around 100 million years ago. So we've been talking about 40 years, 200 years, now we're talking 100 million years ago. This was a sea. You said uplift, so how do we turn that into land? Do you know what the uplift event was that created this land?
I can never remember my period.
That's all right, that's all right. So the most recent event that has been folding the rocks in this area and has created some of these very gentle hills of the UK in the south of England, like for example the London Basin and some of the hills around there, that's all been part of the alpine orogeny. Orogeny is a mountain building event. So it's not just the event that created the Alps, it's actually all of Africa pushing up into Eurasia. Because tectonically they're one, Europe and Asia. And that's been going on for about 200 million years. And we're kind of on the flanks of that. We're not close to the suture zone. And so we don't have these strong folding forces that create things like the Alps. But we do feel the stress in the far field. And so, okay, near the Alps it's really getting crumpled. But over here there's still like some soft folding. We don't quite escape the stresses. And that's what's uplifted the land around here. And why these guys are now above sea level.
Sorry, when you say it was tropical, is that because, you know, the whole continent has moved
Yes.
up from the tropics?
Yes, so tropical as in it was that latitude. Additionally, the Earth was much warmer. So we were in a much warmer period when it comes to the climate. So the Carboniferous was even worse than the Cretaceous, and it's called the Carboniferous because the rock record is so full of carbon that was in the atmosphere at that time. Who's to say? You know, Earth goes through its cycles. So climate change is a part of Earth, but we've been speeding it up too much. So we've been speeding it up such that nature doesn't have a chance to recover. So we will certainly wipe ourselves out if we carry on this way. And I think probably Earth will correct, you know, we'll just be a little blip in its history. So if we carry on as we are, we'll just bring another Carboniferous quite soon. Whereas normally it would still be another couple 100 million years away. Who knows? But just to give you some perspective, humans have not been around for very long. I mean, Earth, the age of the Earth is 4.5 billion years. So that's one with 9 zeros, not million, like we've been talking about million years, which is 6 zeros. So 100 million is one with 8 zeros. But Earth has been around for 4.6 billion years. If we pretend that that's 24 hours, one day, out of that time, humans, we can say, have been around for just a minute and a half. You know, our legacy is really very short, but we might leave a long-lasting one in the aftermath. But we are a tiny, tiny blip at the moment, you know, a part of a much, much bigger system that we just don't understand very well. Are you happy to stay in deep time, or do you want to come back? Thank you all. Thank you for engaging. Thank you, Morag, so much. Thank you.